and check the sound level, making sure that the sound level is right, because I don't want everything to appear on this end, clipping everything, and I don't want everything to be on this side, which means it's not loud enough. I can bump it up a little bit. Okay, I'll call that good. If you guys think this is not loud enough or too loud, let me know, and in the next class I can adjust the sensitivity of the mic. All right, so we got that out of the way. All right, and I have another good news. We have the first homework assignment.
Yes.
Well, this is an easy one, but it is a very important one. The point value of this assignment is 5 points. It's 5 points out of maybe around 600 or something like that, and the 600 points makes up 20% of your final grade. So this is 5 over 60 times 20% of your final grade. Okay, but it's important because this is what you need to set up the infrastructure. Okay, basically all the tools, all the folders that you need to do your homework assignment. It is all being recorded right now, so if you cannot remember the Linux commands or how to do something, you can always watch the video again to make sure that you can get those ideas. Any questions at this point? I'll go through this and I'll do it once myself here, and it will be shown on the screen. Yes? It's also a part of this too. It's part of the demonstration, so don't miss the demonstration. It's really helpful. Okay, so I'm gonna open up a new tab here and do my own homework assignment. All right. Well, I cannot do the whole thing, but I can do a part of it at least. The first step is to make an identifiable account. In other words, if everybody turn in their homework as the user, I can have no idea who is who. Okay, so all of your points will go to a user student account that I will create in Moodle, so that student will pass this class with a grade of A. Okay, so instead of using the user account, the generic account, I want you to create your own account with your last name as the account name. Okay? The question is, how do we do that? Well, I'm giving you the commands to do it. The first thing you have to do is to go and use the su command to become the root user or super user. And after that, you can use add user and use your last name as the account name. I haven't checked whether there are two people with the same last name. I don't think so. Let me check. Let's just do a quick scan here using surname. Okay, so far. Nope, we're safe. All right, so that's good. So use your last name. Now, whenever you see italic here, that means you have to replace it with something else, something that is specific to you. In this case, I don't want anyone to create an account with the name last name. Okay, that is not what I want people to do. I want you to substitute last name with your actual last name. Is that good? All right. And use lowercase too, all lowercase. And then you can exit from that particular prompt. So just to give you an idea of what it looks like, I'm going to do exactly the same thing. SU, it will ask you for the password for the root account. It's ball, B-A-L-L. And once we switch to the root account, we can run the command called add user. In my case, I use my last name, A-U-Y-E-U-N-G. And it will give you the prompt. It will ask you for stuff such as the password. If you forget the password, it's no big deal, because as root, you can always reset the password of somebody else. So I'm just going to use a simple password here, retype it, and it will ask you for full name and stuff like that. Just enter is fine. Okay. So that's all there is to it to create a new account. Now in here, I can actually switch to that newly created user without having to log out and log in again from the GUI. But for those of you who are not really used to Linux, the safest way is to log out as the regular user and then log in again using this new account name. Okay? And from now on, you should probably just use that account instead of user. But since I already know, my way around Linux, I can just use su. Switch user can switch to root. It can also switch to any other user. In this case, I can switch to my newly created account, but use cd to change to the home folder of that account, and I'm all set up to go. Yes?
Won't other people get to access your account too when you do like that?
But this is inside your virtual machine.
Oh.
And you own your virtual machine, so you're safe. Yes?
How come you just took, was it just SU that you typed in the first line?
Yes.
So that accesses the super user, but if you use SU and then the different account number, that's
Yes.
Okay.
If you use SU with an actual user account name, then you are changing to that particular user account. If you use SU without an account name, then by default it will try to change to the super account, super user account. Yep.
I don't see it prompting you for password.
That is because I am switching from root to a regular user account, so I'm actually decreasing my level of privileges, and that's fine.
Okay.
Yeah, it will only ask for a password when you're elevating your privileges, but not when you are, bumping down. Okay? Any questions at this point? No questions? All right. So moving back to the homework assignment. After all these steps, you can log out as the regular, or the default user, and then log in as the identifiable user. All your homework and exam-related work should be done using this account, and don't forget that, because otherwise I cannot identify who did what. The second step talks about the folder structure. The folder structure basically says when you first open up a terminal, it will, okay, let me clear the screen, it will look like this. Now, this is really important because the prompt tells you where you are in the file system and on which computer, at the same time. The first part here tells you that you are user, this is the username that you're logged in as. Okay, so that is really quite useful. Now, this part is useful too because the tilde symbol, which is the squiggly, is the symbol for your home folder. Every user has a home folder. Well, I shouldn't say that. I should say most users have a home folder. Some users do not have a home folder, but most users do. And this tells you that you're at the root or the top level of the home folder. It is kind of equivalent to documents in Windows. Okay, sort of, not exactly the same. I don't want you to create program files over here because over the course of time you will have lots and lots of files and it will get very confusing. So I want you guys to use subfolders to organize your homework assignments as well as your answers to questions in the exams. Okay? So let's go back here. So in this case, I want the folder to be called test. And you have to follow these names because I am going to write scripts to help me grade the homework assignments. And if you are not using these names, my script will not pick up your submission correctly, and then I will have to do it manually, and then it's going to cost you some points. So I'm going to run this command, mkdir test. Okay, it stands for make dir or make directory. Now some of you are really curious. You want to find out the 20 gazillion ways of using make dir. That's a good thing. Use man. Okay, man stands for manual, and just about every command in Linux are documented in the man system. So when you type man mkdir, it shows up what we call the man page or the manual page of this command make dir or make directories. You can scroll using the page up, page down keys, and it shows you the command, the different options you can supply to this command to make it do different things. Any questions about this? Yep.
Your grading script, does it grade right away or?
No, it doesn't grade right away. Yeah, it will. I will actually write the script after the due date of the homework assignment. Okay, because I don't recycle my homework assignments, so my grading script from last year can only serve as a template for homework assignments this year. assuming I remember how I wrote my own code last year. Most of the time I have to reinvent the wheel. Okay, to get out of this is Q, okay? So just type Q on the keyboard and it will get you out of the man page. Any questions? No questions? So what if I want to find out how to use man? You just say man, exactly. Man. And there you have it. There are other jokes, but I decided this may not be the appropriate place to tell those jokes. So I'll refrain from other man jokes. Okay. Now that you have created a folder, you have not really changed your current working directory yet. Okay, so there's a concept called a current working directory. When you look at the command line prompt, this part tells you what is your current working directory. The concept of a working directory is for your convenience, because if you type, if you try to edit a file or create a file without specifying the full path to that file, it will be assumed to be here, in this case, in the home folder of this user. Okay? But I don't want to create any files here. I want to create a file inside a subfolder. So the first thing I want to do is to change my working directory to the subfolder that I just created. The command to do that is cd, okay, change directory. So you just say cd, and then you give it a name. In this case, it is test. And you can see the prompt has now changed to reflect my current working directory is no longer the home folder, but one level down from the home folder. Is that, yep?
What's the dollar now the sign stands for?
The dollar sign is the quote-unquote classic prompt for the command line. So if you don't set it up in this way, a lot of times the shell will only give you the dollar sign. Okay. If you run a terminal emulator in Android, that is the default prompt it will give you. If you root your phone, then it will give you the pound sign. Don't ask me why, I know. I don't want it recorded. Okay, once again, what if I want to know the 20 gazillion ways to use CD? Man, CD, there's no entry for CD. That's because CD is not a real command, it is actually an internal command of bash. Okay. Bash stands for born again shell. No, really, you think I'm joking, but that really is the case.
Born again shell.
Man bash. GNU born again shell. I wasn't kidding. All right. Okay, now that we are here, we have to create a file, okay? Because I want you to walk through the whole process. Do you guys have any questions? Anything I can answer? Okay. So I want you to go through the whole exercise. This is a walkthrough of what you typically have to do for all your homework assignments. So in this case, I want you to create a file called simple.lowercase(s). The case is sensitive, okay? You want to use the lowercase. Linux, for the most part, or all Unix systems, for the most part, are pretty much, extension insensitive. But some of the tools that we use, especially for development, are sensitive to the case. So I just want you guys to have the right habit to use the right extension for the right kind of file. And the content of the file is really just these 5 lines. So now the question is, how do I do this inside a Linux environment? The easy way, since I give you the entire GUI, the easy way is to go to Applications menu, go to Accessories. Instead of Notepad, you look for a mousepad. Switch back to the terminal, the browser, select, copy, switch back to the editor, paste, and then save the file to the right folder, and you're all done. So you go to File, Save, go to the right folder. Now remember, this is a problem that I will experience because I'm still using the user account, the generic user account here when I start up mousepad. So that's why I have no access to my other user account. So I can't really save the file to the right place because the users do not have permissions to access each other's folders. Okay? But since you will be logging out and log back in again, you will see the subfolder called test in your system, and then you can just double click and get into that subfolder and then save the file as simple.s. But let me show you another way to do this. It's even simpler. Yes?
What's the hotkey to switch between windows?
Same, Alt-Tab.
Alt-Tab?
Yep. Just like that. Let me show you another way to do the same thing, and it's easier. And you guys will ask, but what possibly can be easier than this? Browser, select, copy, editor, paste, save as. All done. This is even better. You use cat. Cat greater than the name of the file. Press the enter key. Tag, I think you're just trying to trick me because nothing happens. Okay? Well, let me just finish this whole process and then I'll explain what just happened. Go back here, do the selection again, copy, switch back here. If you know the shortcut keys and also the mouse shortcuts, you can do that. But assuming you don't, this is the first time you do it, just say, paste. Okay, so you paste the text that you have, but still, nothing happens. Okay, the prompt is not coming back. Press Control D to make it come back. Run the ls command with a -l. Now I just confirm that I have created a file called simple.s. This is the date, and it belongs to me, and these are the permissions. They are not important in this class. Okay, what just happened? Well, let's take a look. Cat stands for concatenation. That really is the name of the command. It's concatenation. It's just an abbreviation of that. The greater than symbol is redirection. In other words, it can change the output of this command. Instead of sending the output normally to the screen, to the console, it's now sending it to the file that I specify next to it. In other words, simple.s becomes the file that captures the output of running the command called cat. So what exactly does cat do? It's the same as type in DOS. All it does is you can specify a file and it will display the content on the screen. But tag, you did not even specify a file. There's nothing here. It's just an empty space here. If you don't specify a file, it's going to use the keyboard as the default input file. Okay, so let's combine this whole thing and figure out what this one line is telling you. It's telling the system, copy whatever the keyboard is, whatever the keyboard has, copy that content to the file called simple.s. That's basically what it's doing. And that's why you see the prompt just blinking without doing anything, because it's waiting for you to type something on the keyboard. Okay, is that okay so far? Yes? Okay. So that's why I can paste all this stuff here, and at the end, the cursor is still standing there doing nothing because there's nothing else to do. It's still waiting for you to type some more, even though we are already at the end of the program that we want to type. So the question is, how do we get out if we cannot stop typing? Control D has a special meaning in Linux and all Unix systems. Control D means end of file, EOF. So when you type Control F, the system recognizes that control key as a special symbol, and a file. So it will say, oh, so you're done, specifying the file, from the keyboard, and that's why it gives my prompt back and finish creating that file. In this class, I will not ask you what just happened or why it happened. I just tell you this is a shortcut to get things done. In other words, if you cannot remember how to get this done, you can use the other way, copy and paste into a notepad or mousepad, save, inside the mousepad. It works just as well. Any questions about this approach? No questions? Okay. All right, so back to here. And definitely, You don't have to understand what this means. Okay? Within the next 2 or 3 weeks or so, we will definitely get into this, and we'll have a much better understanding of this part, this really simple program. I can tell you only one thing. It's the same as a C program, but inside main, you only specify exit 0. It's equivalent to a C program that only exits from the program itself. All right. So we are done with this step here. We are now down to step 4. Step 4 says, we have to use this command to assemble the source code. The name or the term assemble really means the same thing as compile, but we use the word assemble instead of compile because the assembly language is a much simpler language, so we don't really use the word compile because it is a lot simpler. But the process is really the same. The file that I have just created is nothing more than a text file. It cannot be executed. The processor does not understand that at all. The assembler, on the other hand, will convert or translate this into machine code that the processor can understand. And that's what this command is about. When you look at this command, AS is the name of the command. It is the abbreviated form of assemble. --G stabs tells the assembler retain symbols for debug purposes. Now for this homework assignment, we're not going to debug it. Okay, it's a very simple program. There's no need to debug it. But I want to include it here just so that you have a good habit of including --G stabs in your command line when you assemble the file. -O means I want to specify the name of the output file. In other words, the file that will contain the actual machine code will have the following name, simple.o. Once again, this is a convention to use .o as the extension of an object file. If you use .obj, nothing is going to complain. Okay, you can use any file name you want. You just have to do it consistently. But as a convention, people use .lowercase o to mean an object file. The last portion, which is simple.s, specifies the source file that you will be using in order to produce the object file. Okay, any questions?
And you have to be in that directory.
Yes, you have to be inside the directory for all these steps to happen. Okay. Now, you see a £sign here and then some explanations of the command. You can actually include that when you copy and paste it on the command line. The £sign in Bash and in many, many other programming languages in a Unix or Linux type of environment means this is the starting point of comments. In other words, the £sign and everything to the right-hand side is considered comments. It's not going to be interpreted by the command line interpreter. So that's why it is safe to copy the entire line and put it onto the command line because everything from the £sign is just not going to be processed. Let's try that. Okay, I take the entire line, go to my command prompt, paste it, and ran it. Nothing happens. So it would seem. If you see any feedback from the system, that means you have a problem because the assembler that cannot assemble the program. Then you have to check the content of the text file to make sure it is exactly the same as what I specified. In this case, there's no feedback whatsoever, but I can do I can confirm that this is actually successful because it just created a new file, simple.o from simple.s. Simple.o is a file that contains the machine code that your processor can understand from the file called simple.s. Are there any questions at this point? Yep.
Are all assemblers created equal, basically, throughout all subsystems?
Say again?
Oh, okay, like, I'm thinking it's like a C++, whatever. We usually use a compiler, right? There are
Right.
many different compilers.
Right.
Are all assemblers created equal? Are they the same, basically, in any system, or are they different?
You mean the format of the object file?
Yeah, just like you can use command line AS, but we didn't download an external assembler program or whatever to compile it.
This is built in. I included the tool on the live DVD itself. If you install, I think it's bin-util, as a package that includes the assembler. That's this distribution and architecture dependent. But when you install that under the Debian system, it always installs the right one.
Okay.
but you're asking about the format of the file, the
Yeah.
.o file. The format of the .o file is actually language independent. In other words, if you use GCC and specify the -c lowercase c option to create the object file, those files are actually compatible with the file created by AS. Is that helping, or am I answering the question? Sort of.
I'll pick up on it for sure.
Okay. All right, so it seems like the process is done. I mean, we have the object file that actually has the machine code that the processor understands. So should we execute simple.o? Unfortunately, the answer is no, it is not yet time to execute the program. But why? Why not? I mean, we have this file, simple.s is a text file. The processor does not understand that. The assembler is a translator. It translates the text, version of the program to the machine code that the processor can understand. So what is missing here? Why can't we execute the program just yet? That's one thing that we'll talk about later, because now this is a really simple program. It only has 5 lines, but real programs have hundreds of thousands of lines easily. Okay, broken up into 50, hundreds of files. So now you have to remember that each source file creates one .o file. When you have 100 source files in .c, as a C file or C++ or whatnot, you end up with 100 .o files. Which one are you going to execute? None of them. So that's why we have to go through the last process called linking in order to create the executable that is actually ready to be executed. So the last step is called LD. That's the name of the linker. So I'll just do the same thing here. Copy, and go back here and paste it. And once again, the command succeeded because it does not give me any complaints. And once again, I can use ls-l to confirm that. So now we have simple, which is the executable, simple.o, which is the object file, and simple.s, which is the source file. How come simple is highlighted in green and is bold-faced? Because it's executable. Okay, that's the syntax highlighting. So now it's time to execute that program. All right, let's execute the program. It does not work. Command not found. That's because the current working directory, which is also represented as a single dot, is not in the path environment variable. In other words, the Linux operating system, well, I shouldn't say the operating system, but the command line interface, there is a certain set of folders where it will try to find commands. When you just say, what did we do? mkdir, it's going to search through each and every one of those folders until it finds the command, in one of those folders. The current working directory is not on that list. And therefore, when we try to execute simple, which is in the current working folder, it cannot be found. The command line does not know where to find that executable. But that's okay, because we can always give it more information. Dot means the current working directory. Slash is the separator between items in a path. So when you specify ./simple, that means go ahead in the working directory, find the executable program or file called simple. And that should work. Press the enter key, segmentation fault. I must have forgotten something. Let's see.
Debug.
I think I know why it's not working. I forgot a no op instruction. It's okay. Well, should I fix it? I'll fix it. .c. I think it just needs a no op. Maybe not. Okay, here's another shortcut. Exclamation point means recall the previous command that starts with the following. So if I want to rerun AS with everything else being the same, all I have to do is to say exclamation point AS. The same thing with LD, and then I can just run the command again. This is bugging me. This is definitely bugging me. How can a simple program like that, crash with segmentation fault? Okay, now I want to find out why it's crashing. Receive segmentation fault. That works. It's the software interrupt that is not working. That's why it's not working. I know why. I'm going to have to change the homework assignment to reflect that so that you guys, have a better head start here. This needs to be 1, and that needs to be 0. I'll explain all of this stuff later, okay? Assemble, link, run the program again, and this time it works. I'll explain all of this stuff later. EAX, serves a purpose, EBX serves another purpose, and I got it all mixed up. So let's change the homework assignment so that you guys don't get the segmentation fault. Just empty space. I'll explain that later. This stuff will be explained like pretty much in the middle of the semester. That's the time frame to explain this. But to give you guys a hint, int $0x80 is the interface to the operating system, to the kernel. Okay, it's saying, hey, kernel, I need to get something done. What do you want to get done? That is expressed by the content in EAX. So when I specify the wrong value, 0, the kernel says, I don't know what you want to do, and gave me a segmentation fault. We'll explain all of that stuff later. For this homework assignment, you just have to copy and paste the code, go through the assembling, the linking, and that's about it. All right, the last step, pack it all up so that you can send it to me as your submission. So I want everything. I don't want just the source code. I want everything in your folder. So the way to do it is to run this command here. tar stands for tape archive. A lot of these commands are very archaic. Okay, they come from way back when we still use tapes. However, this command is also very useful for stuff like this. Okay, I just want to create an archive file, according to a particular path. Without even asking why or how this command works, let me just copy and paste it. And this is how it works. This is the output of the command. Basically, all it does is it will combine all the files in the current working directory, which is test, and create an archive file that you can upload to Moodle, and that's what you need to turn in. Okay. So where is that archive file? The archive file is actually in your home folder. Okay. If you move one step up, when you say cd without actually specifying where you want to change the directory to, the default is the home folder of this user. So I just changed the current working directory all the way back to the home folder, because you can see on the prompt that only a single tilde sign is remaining. That means I'm in the home folder again. The tar file is test.tar.gz. The gz means the file is compressed. Okay, it's gzipped. Tar means the file is an archive file created by the program called tar, and test obviously reflects the name of the folder, which is test. Okay? It's going to be pretty small because we haven't really created a large file. So the tar file itself is only 684 bytes. And that's why I said, if you allocate 2 gigabytes for your persistent drive, you should have way more than enough space for homework assignments in this class. Next question, what do we do with this tar.gz file? And how do we use Moodle to turn in our homework assignment? I don't see any way to turn in the homework assignment here. Well, that's because I have not switched my role to a student yet. So let me do that first. So I'm going to switch my role to a student, which will basically display what you will be seeing when you log into Moodle. Click on the homework assignment, scroll all the way to the bottom, and this time you will see, choose file so that you can upload the file. So I'm going to click here, go to, it's not going to show up here because it is in the wrong, folder. But let's just say that I want to upload, a particular file. Doesn't matter which one. I just want to use it as an example. I'm going to pick one small file, funky.ods. That's one of the homework assignment of my cisp310 class. So once you specify the file, you have to remember to click upload this file. Wait a little bit. And then Moodle will confirm file uploaded successfully. If you click continue, it will show the same page again, except this time it will also give you a hyperlink to re-download the file that you just uploaded. Okay? And I have set it up so that you can upload as many times as you want before the due date, which is a week from today. So if you want to finish it halfway, and upload it, that's fine. Just remember to upload the finished product at the end. Any questions about this process? Yep.
Just to remove this confusion of ways the user, how can we somehow just delete this user account?
And start from scratch?
Well, and simply using our account, like.
Oh, you want to delete the default user account?
Yeah.
I wouldn't do that, because I would just kind of keep that one around. The reason why I do not recommend that is because the user account is actually quote unquote burned into the DVD. So if you delete it, yes, you can have the effect of deleting the user account, but it's always going to be quote unquote there, in the shadows. Just remember to use your regular user account when you log in.
So it's got some kind of like a backup.
Backup of.
Backup of all the essential files.
Okay, that's a good question. Now, many of you or all of you should try to back up your files as much as possible, especially right after you get the homework assignment done. And you probably don't want to lose other homework assignments, just after you get one done. So the way to do it, I cannot show it here because I'm not running a virtual machine anymore. But when you run the virtual machine, remember the file called disk.qcow2? You still remember that file? That one single file in Windows represents the entire drive in Linux. All you have to do is to back up that one single file. Because everything else you can download again and reinstall. The qcow2 file is the only file that contains your data, your files, your homework assignment. So just make backups of that file and everything is backed up. All your homework assignment, all your user settings, all your browser settings, all your bookmarks, everything is going to be backed up. Any questions about that part? No questions? Okay. So do you guys think realistically you can get it done in 168 hours minus 40 minutes?
It's kind of close.
Cutting it close. Now, if you have not used Linux before, I would suggest you to get started as soon as possible because a new environment, the command line prompt and stuff like that can take a little bit of time to get used to. So you can always re-watch the video. Okay, the video is always there on YouTube, which brings me to the next topic. Where do I find a video? And also the other stuff that you have promised on Tuesday. Go to YouTube, type some profs, and then locate the channel. Now that you have located the channel, I would just subscribe to the channel, just to simplify everything. And let's see. Well, I logged in as myself already. Now, how do I find the video of this channel? Do you guys know? Oh, there we go. Just clicked it. Oh yeah, that's so complicated. Okay, so when you click it, you will see, you can bookmark this part too. You can just bookmark this URL, so that way it will bring you to the some profs channels really easily. The list of video files is sorted in reverse time order, so the most recent one is always listed first. So from here, all you have to do is to look for the class name. This is not cisp370. It is cisp310. So when I upload the file, it's going to have almost the same format, the date and the class code. So those are the two items that you need to use to search for the video recording of a particular class. Are there any questions about this? Tag, what about the stuff that you talked about on Tuesday? Because I did not record anything on Tuesday. Well, it's all here. If you look at this part here, Dev Live part 104, Dev Live part 204, 304, and 404, that's the stuff that we talked about on Tuesday. Okay, any questions about this part? Yep.
I thought you said you were going to talk about NVIDIA drivers or something like that in the card. Right?
With the NVIDIA driver, I don't know whether this machine actually has an NVIDIA card or not.
Okay.
Since it starts up without any problems, I'm assuming it does not have an NVIDIA card. Now, if you have an NVIDIA card, I have another instruction just for that, so I can talk about that later. Okay. Any other questions? Yep.
I think I asked on Tuesday, but you said that if you have a Linux machine running a different distribution, that you could do all the homework for the class on that one.
Yes.
So, for instance, I use Ubuntu. So, assuming it's 32-bit, I would create a user with my last name and then just do all the same instructions.
Yes. You might have to install additional packages for that. The one package you definitely want to install is called bin utils. Yeah, bin utils you definitely have to install. There might be some other ones, I just cannot remember. GDB is one that you have to install as well. You don't really technically need GDB, but it's very, very helpful.
Most of these will probably be on there by default.
I do not know, because Debian does not automatically include bin utils or GDB. So I have to include those packages manually.
All right.
Okay. Yep.
What about if we have an account to Power? Okay.
We do not, well, do you have an account on Power for other reasons?
Yes, from a different class.
From a different class? You can do it on Power, and the Power username already starts with your last name, so that requirement is definitely met. The only thing about using Power is, if your program goes, crazy, it's going to affect, some hundreds of users. And it also needs an internet connection all the time, whereas if you use the virtual machine method, it does not require any type of internet connection. So it's up to you, if you already have access to Power. I believe Power has all the tools installed already too.
Okay.
Yep. Any other questions? Yep.
It looks like I can do the whole homework and the file and then zip it on window. I don't know about the zipping, but I can do everything else on window. So
I don't see how you can do the assembling or the linking in Windows.
I can. There's another way where I compile and link it on window because I took another
The language is different. Okay, even though in Windows there are assembler for the i386 or the x86 processor, the syntax of the assembly programming language is different. In Windows, most likely it's going to use the Intel notation. In this class, we use the AT&T notation. So I don't think you can find a compatible tool that will work in Windows. As I told one of the students before, if there's a harder way to do something, I will choose and use the harder way to do something. So that's why we're using Linux. When we could have been using DOS, yes. Any other questions? No other questions? But seriously, I think learning how to use tools inside a Linux or Unix type environment can only be beneficial if your plan is to move on to a CSU or a UC. Because many of those schools have set up their workstations to be Linux based or BSD based. So sooner or later you will see the same type of work environment. It's just that at which time do you want to transition over? That's the only question. All right, so if there are no questions.
Why is your date and time a little bit off?
Sorry?
Why is your date and time a little bit off? It's like January.
Like date and time is a little off? This one? Oh, it's because I can explain that one too. Okay, that's a good question. The question is, how come this time, seems to be off? It is, let's see, forward. About 7 hours, forward. It's because of the way the real-time clock works and the way Windows wants to keep the real-time clock in the local time. Okay, inside the computer, when you turn off the computer, for some reason your computer can still keep track of time, and that's because of the real-time clock device in your computer, which requires a battery to run when you turn off your computer. The real-time clock, is just a clock. It doesn't know its location. It doesn't know that we are in Sacramento. So it only keeps track of, the time. Well, when your computer starts up, in Windows, Windows make an assumption and say the real-time clock is reflecting the local time. Local time means, Pacific Daylight Saving Time for us. But Unix is different. Linux is different. Linux wakes up, it grabs the time from the real-time clock and says, I think that's Greenwich, that's a new name for that, UTC. Okay, that's UTC. Okay, which means exactly the same thing. And that because of that interpretation, the time is off because the machine normally uses Windows, but I'm rebooting it using Linux. So in Windows, it's actually the real-time clock is reflecting the local time, but in Linux, it thinks the local time is UTC, and I changed my time zone here to Pacific Daylight Saving Time, and that's why it is off. However, Moodle is local time, so all the stuff that I talked about in Moodle, that's local time. And you have to be careful because I know someone is going to fiddle with the profile settings and someone's going to change the time zone setting in Moodle. If you do that, it will only change how time is displayed from your perspective. It does not change the actual due date of the homework assignments. I have gotten that one before, so I can mention that already. It's like okay, yeah, somebody is going to do it, and somebody is going to say, but I thought I still had a few more hours. No, you don't.
So that machine there also has Windows on it. Did you create another partition, or what are you doing with the hard drive there? Or are you doing it onto a separate?
Say again?
Because you're dual booting that.
Right.
So you have another partition on the hard drive that you're.
Actually, I use one of these things as my second hard drive. Yep. And it's really handy because I can take the ISO image, which is on one SD card, and I can take the persistent drive, which is on another drive. Those are the only two things I need to do. I need to bring with me, and I can plug in both of those to another machine and reboot the machine, and I can use Linux on the other machine too. Yep, comes in pretty handy. Do you guys have any questions? Anything I can answer? No? Not at this point? Okay. If you guys have questions for me, let me know. All right. Let's get started then. Okay, we got almost all the tools available, already done. Okay, I'm over here. Okay, thank you. All right. For those of you who are used to PuTTY, we actually have PuTTY in this distro too. but I don't think anyone will need to use PuTTY in this case. A lot of this stuff is really historical. It really serves no purpose now that I'm using a virtual machine. All right. Well, this slide here, just explains, certain things about Linux. You can ignore a lot of this stuff here. You can ignore 1.2 because you don't need to install Linux. It comes installed on the live DVD. You can ignore 1.3 because you don't have a school account anymore. You can not ignore 1.4, especially if you don't use Unix prior to this class. So start with 1.4 and read that. 1.5 is just repeating stuff that I just talked about for the most part. So definitely read that part too. And 1.1 is just my marketing spiel to talk about why I use Linux to teach assembly language programming. Okay? Any questions about this particular slide? No questions? Okay. There's nothing here that will appear in any exam because there's nothing that is worth asking questions of. It's still useful reading though. It's still useful. Now this one I want to go over just a little bit because there are people always asking me this question, inside the classroom or outside. Why do we have to learn how to program in assembly language? That seems so useless, right? Are you guys going to become developers, software developers, or software engineers, something like that? Okay, the majority of you are going to become, programmers or software engineers. What language do you think you'll be using to write, your programs? C++ for a lot of the system type of software. Maybe PHP and Perl for scripting, web scripting, or any type of scripting. Perl is good for that. Python, which is actually slowly replacing Perl. Visual Basic for commercial, business type of software. Anything else? Any major programming language I have missed? Java. Okay, so there's Java for everything else. Well, just about everything else. And Objective-C if you want to program in iOS. Okay. Okay, Ruby, COBOL. If you want to make money, you want to learn COBOL. Okay, that's the. I mean, I'm not kidding.
No, I'm not.
Yeah, because because the population of COBOL programmer is decreasing very fast, and corporations are not giving up their COBOL system programs. So learn COBOL if you want to make big bucks and want to avoid the competition altogether.
Same thing with Fortran.
Okay, I don't hear assembly language programming. Okay, so who in their sane mind is going to program or write programs in assembly language?
Hardware drivers.
Hardware drivers, people who write the BIOS. Okay, because you have no assumptions when you start up a machine. Anything else?
Highly optimized code.
Highly optimized code. Yep.
Reverse engineering anything?
Reverse engineering something. People who want to write exploits, viruses, definitely want to write in assembly. Yep.
Kernel development, emulation development.
Mm-hmm. Emulation environments. Anything else?
Engineering something new.
Well, if you want to program one of those, MCUs or microcontroller units that only cost about 60 cents each, you probably have to program in assembly language. Now, what am I talking about here? I'm talking about a chip that's about half the size of your pinky, and that's really big. It's mostly just the packaging being that big. So the chip is really tiny, has about 8 pins. You give it ground, which is 0 volts. You give it 5 volts or 3.3, depending on the chip, and it will run. It has space for the program itself, which is stored in flash. It has RAM, and it has I/O devices. You can use it to turn on something. You can use it to sense whether something is on or off. And you can do a lot of really cool stuff using the MCUs. The MCUs can go down in price to as low as about 60 cents each. And that's how we can afford to put processors in just about anything. Okay? The downside is the cheap devices only has 1 kilobytes of space for your programs. Yes, I said 1 kilobytes, as in 10,024 bytes. You only have 32 registers to play with. That's your RAM. Okay, 32 bytes of space to play with for all your variables. Are you going to program in C? Are you going to program in Visual Basic? You are going to program in assembly. Okay, so that's a very niche type of market in programming, because not a whole lot of people have to deal with that sort of thing. So what about the rest? The rest, the 99% of this class who will never touch assembly language programming ever again after this class, assuming passing this class the first time. So why are you here? I mean, is this a class just so that I can make sure that I can get my pay as a teacher? Let me show you something then. Let me show you a interesting program. C code. I'm making assumptions that an assumption that everybody in this class should be able to read this program. Yes? No? If it looks mysterious to you, this is not the right class. I'm not kidding. I'm not trying to belittle anyone in this class. I'm not trying to do that sort of thing, because if this program looks foreign, the rest of this class is going to be really hard. Okay. All right. So let's just look through this program. We have a subroutine called G. It does not take any parameters. It does not return anything. In other words, it's for the most part useless. And yet it has a local variable called X, which is an array of 4 characters. There's an assignment statement to change one of the bytes to D0 in hexadecimal. There's a subroutine called F, and all it does is to print, this is weird. And here's the main program, the entry point of the entire program. It calls G, it prints, this is not too weird, and then it returns, basically it exits the whole program. In other words, F was never called, right? So for some reason I wrote a subroutine in this program that was never invoked. I never called it. Okay. Let's see what happens when we run this program. Okay. I'm just going to create a folder for today so that I can put all the files for today into this folder. 01, what is it, 19? All right, so do the same thing here. I'll call this program badret.c.s. Oh, it's .c. Never mind. I'll change that later. All right. This is a very good opportunity to teach you guys another command in Linux, because I just made a mistake. Yes, I made it intentionally, so I can explain this new command. Yes. All right. So how do you rename a file? In DOS, it is rename, REN. In Linux, it is MV, move. Okay. Now, move is actually, it can do 2 things. You can move a file from one folder to another, but inside the same folder, you can also use it to rename a file. So in this case, I'm just going to rename badret.s to badret.c so that it will be picked up by GCC. I'll go ahead and compile the program. GCC. I'm not going to specify any optimizations or anything like that. I'll just compile it to the way it is. -O to specify the name of the output file. You can see that different commands in Linux a lot of times share the same convention. Okay, -o to specify the output file. It's going to be an executable because I want GCC to do all the linking. I don't want a separate command to do that. Give it the source code, compiles without any problem. Go ahead and run the program. It doesn't print anything. Wait, is it supposed to not print anything?
No.
It's supposed to print something. Okay, let's mess around with this program a little bit and change this value a little bit. Let's change it to D to 80. Okay. Segmentation fault. That's weird. Let's change it to something else. Yeah, let's change it to 40. And it prints nothing. What I'm trying to do is to make it print something that is completely mysterious. So far, it is not so completely mysterious at this point. Yep. Since it started off with 8, I can now try A, off by 16 bytes each time. Still doesn't do anything. Let's try C. It's a this is an iterative process because I don't know exactly what value will make it do the things that I think it's mysterious. Let's try F. Yeah, segmentation fault again. I know there's a way to really force it to do what I want it to do, but then it will be giving away the actual code. So that's it's not what I wanted to do. Okay, let me just verbally describe without actually making that happen because that can take a while. If I have enough time, I can make this program to print this is weird and then get out or have a segmentation fault. In other words, I can make this program to go to a subroutine that I never call in main. Okay? But you already saw the symptoms of this program. It can have a segmentation fault. It can print nothing already. Okay, there are 2 symptoms, but they both correspond to the same bug. And there's a third symptom that I cannot reproduce at this point, which is it will actually go into function f, print this is weird, and then after that it may crash. Okay, this is a really simple program. I mean, I can fit this entire program in huge fonts on this one screen. Imagine you have a program that has 300,000 lines and it's doing something that is funky. Basically, it's going into a subroutine that you never called. Okay? How are you going to debug that program?
Painfully.
Call the Ghostbusters. Trademarked. Okay? Okay, but let's take a closer look at this program. There's only one flaw in this program that's causing all of this stuff to happen. This is the one line that is the problem. What's wrong with that line?
The array index is actually larger than the size of the array.
It's out of range, right? The element does not exist. So what is so bad about it? I mean, we're just changing an element that does not exist in that array. So what do you think happens? Go ahead.
I think it's changing the address, which is 8 bytes from the start of the array to that hexadecimal value you set. So
correct.
It's going past the array and then 4 more bytes to whatever happens to be in memory there.
But surely that location cannot be important.
Well, you don't know.
I mean, it's not a part of this array, so it cannot be important. I can trash that location all I want, and nothing should happen. Every location is important, right? So when you're overwriting a byte location that is not a part of the array that is allocated, it's messing up something other than the array itself. As it turns out, in this case, it's messing up the return address of the subroutine. So when the subroutine returns, it returns to the wrong place. So by changing, how I modify that location, I can make it return not to main, but return to function f. So it will continue execution in f, and therefore giving you the message, this is weird. Okay? How many people here can say, yeah, but Tag, that's a really stupid mistake, only stupid people would make. I never make a mistake like that. Accessing an element out of bounds, no way.
You say, does that have to be true?
The problem is you may be very good observing the limits of your own arrays. What if you're writing a subroutine where people is passing you a pointer to the starting point of an array and giving you a length and say, oh, by the way, this array has this particular length. What if the caller is reporting the wrong length?
Shame on him.
Then your program can still have exactly the same type of effect, which means the symptom of the program can make no sense whatsoever. And that is why we need to understand assembly language programming, because in this class, what we are doing is not really to tell you guys to write every program in assembly language. What I'm doing is to show you what is the equivalence of a C program in assembly language, so that you can understand if I make this kind of mistake in the C program, all these symptoms can potentially happen. If I do this in C, these things can happen, and so on. That, I think, is the value of this class. It is not to turn you guys into assembly language programmers, but to give you extra abilities to debug your C and C++ programs. Okay? Any questions about that claim? At the end of the semester, you can tell me whether I fulfill that objective or not in this class. But that's my objective. Any questions? No questions? All right. So we'll go ahead and start with something that's really boring. How to add and subtract numbers in binary. Now, binary numbers is the most boring subject ever. Okay? If we start with binary numbers instead of base 10 numbers in kindergarten, we would have avoided a lot of problems. What is the multiplication table in binary?
Base 2.
Yeah, base 2. Okay. In base 10, every kid in 2nd grade or 3rd grade have to spend almost an entire year to get the multiplication table down. Why is that? How do you know 6 times 8 is 48? It's mostly memorization. If it's not memorization, it is, it's 8 times 8, which is 16. 8 plus 8 is 16. 16 plus 8 is 24, and so on until you work up to 48, which is even worse than memorization, right? How do you memorize the multiplication table in binary? Even if you have to memorize that, it only has 4 entries. 0 times 1 is 0. 1 times 0 is 0. 0 times 0 is 0. 1 times 1 is 1. I'm done. What about addition and subtraction then? Sounds like those should be fairly difficult, right? That's where we start this class. Well, instead of writing it on the whiteboard, I'm going to do it here so that we can capture everything that I do in the class. All right. Let's start with something like this. Okay. What do you say is the result of 0 minus 1 in binary? Well, in binary, I would call this 1 as a result with a borrow. Okay? It's the same as 0 minus 1 in base 10 is 9 with a borrow. Well, the concept of a borrow is very important because that's what allows us to perform multi-digit addition, well, subtraction in this case, and then carry is what makes it possible to have multi-digit addition. Okay? So that means we only have 4 rules to remember when we have binary subtraction. 0 minus 0 is 0 with no borrow. 1 minus 0, you already know that, is 1 with no borrow. 0 minus 1 is 1 with borrow. And then the last one is 1 minus 1 is 0 with no borrow. Does it make sense? Whenever you subtract a value that is larger than the value being subtracted from, you end up with a borrow. But in binary, you only have 4 rules to remember. In decimal, you have a lot more. Because you have to now say, okay, what is 2 minus 6 in decimal? 2 minus 6 is 6 with a borrow. But in binary, it's way easier. Is that doing okay so far? Okay. I think I might have skipped something important, like how to convert bases. Nope, there we go. Okay, I forgot, base conversion. How many people know how to do base conversion between base 10 and base 2? Okay, not a whole lot. So I'll just quickly go over that topic in 3 minutes. Base conversion in 3 minutes, how is that possible? I'll tell you how. How many people think you can work in Safeway or McDonald's? In other words, can you make the right change when people need a certain change? Your machine is telling you, okay, this person is supposed to get $5.76 as change. Can you use the least number of bills and coins for that change? Instead of giving that person 576 pennies, do you know the logic to give that person a $5 bill, 3 quarters, and 1 penny?
Yeah.
You can get it done? You know base conversion. It's that easy. The trick is to imagine a money system where you only have $1 bills, $2 bills, $4 bills, $8 bills, $16 bills, $32 bills, 64, 128, and on the flip side you get half-dollar coins, $quarter-dollar coins, $8 coins, $16 coins, and so on. That's binary. If you can make change in that new system, you know binary conversion, or how to convert values into binary representation. Which one do you think is easier? Who?
Because we know that one.
Our current system is actually by far more difficult. Okay, let's think about why I said that. Okay. Now we are fighting convention the whole time. Okay. The problem itself is simple. We are fighting convention, stuff that is ingrained into our head since we're really, really young. Let's think about it. 1 cent. What is the next value? It's a nickel, right? 5. The next one is
10.
dime, quarter. We do have half dollars, but they are not common, so let's skip that. $1 bills. We do have $2 bills. Once again, they're kind of rare. $5 bills, $10 bills, $20 bills, $50 bills, $100 bills. Do we have $200 bills? Yeah, we do. $500 bills? I'm not rich enough to really find out these things, so I'm just going to make an assumption here. And $1,000 bills. I don't really see a pattern. Off by 5, 2, 2.5, 4, 5, 2, 2, 2.5. There's no regular pattern. As opposed to my other money system, $1 bills, $2 bills, $4 bills, $8 bills, $16 bills, $32 bills. On the flip side, we have half-dollar bills, or half-dollar coins, 4th, 8th, 16th, and so on. Which one do you think has more of a pattern to it?
Binary.
The binary system. Okay? And the best thing about this is when you work with this particular system, you need to know division. Because that 76 cents, how do you know you need 3 quarters and 1 penny? It's because of division. 76 divided by 25 is 3 with a remainder of 1. You can either do that or you can do the repetitive process. 76 cents is more than 25 cents. Here's 1 quarter. 76 minus 25 is 51. 51, oh, it's more than 25 cents. Here's another quarter. 51 minus 25 is 26. You can use that process too, but division works faster. Okay? The best thing about binary is you don't need division anymore. Okay? It's all comparison, just comparison. Let's figure out how to make that work. Okay? I'll just give myself a certain example here. 19 and 7/16. Okay? Looks pretty nasty to me. All right, what do we do? Remember what I said? It's just compare and subtraction. All right, so I will even be dumb enough to start with 32. 19 versus 32. No, there are no 32s in 19. Move on to the next one. There's 1 in 16. Okay, so we say $116 bill, but the amount is now reduced to $13. Oops, excuse me, $3 and 7/16 dollars. Okay, and I will just move down this list here. We're done with 16. There's no 8 in 3 and 7/16. There are no 4s in 3 and 7/16. There's 1, 2. All right, so let's pick up that $2 bill. The amount of change is now reduced to $1 and 7/16 dollar. Move down the list. Oh, there is 1 in 1 and 7/16. Okay, so pick that up. So it only becomes 7/16 at this point. Oops. Do you guys see what I'm doing here? The logic? Okay. All right, so we are now moving from $1 to the fractionals, okay? Is there a half in 7/16? Nope, okay, skip that. Is there a quarter in 7/16?
Yes.
There's 1, okay, so we'll pick up one of those quarters here. Say 1. Oh, is it possible to be a non-1 here? Is it possible to have a 2 or 3 or something like that? Not possible in a binary system. That's why it is so nice. It's just compare. There's no division. Okay? Well, but once I pick up the quarter, I will have 4/16 already taken care of with only 3/16 remaining. Is there a 1/8 in 3/16? Okay, that's 1. All right. Pick 1 up, and the remaining value becomes 1/16. Is there a 1/16 in 1/16? There's 1. Okay. Subtract that from the amount that I'm supposed to give back to the customer. Now I got 0 left. I have just converted a value into binary. Yeah, but Tech, you're just specifying that value in bills and coins and whatnot. How do we write this number out as a binary number? You just have to tilt your head a little bit, like that, and then put a dot here. Okay. So this number, if you want to express it in a more conventional way, it is 0.10011.0111 in base 2. That's why I said if you know how to make change, in working for McDonald's, you already know more than what it takes to do base conversion. Yep.
What if you start? What if you don't have any 64 either? Where do you know where to start?
Where to stop or where to start?
Because you have 1/16 on top and you have 16 and you have 32 on the bottom.
Oh, that's just arbitrary.
I'm going over and doubling the last letter like
Yeah.
64, 128.
Yeah, I just chose this range arbitrarily, just so that we can get a feel of the conversion process. Okay, so it looks like binary as a number system is really easy to deal with. Why did we start with base 10 to begin with? I mean, that's just wrong. That's not enough reason. I mean, we could have started off with base 20 then, because we got 10 toes too. Except we can't really curl the toes as easily. Okay, so are you guys feeling a little bit more comfortable with binary numbers now and how to represent values in binary? Yeah? Now this is election year. If I were a politician, my platform will be convert everything to base 2.
They tried to go metric, and they couldn't get that to go either.
Metric is not as smart as binary. Forget metric.
Oh, but it's better as a standard.
We don't care what the Europeans are doing. We want binary. Base 10 is also wrong. Base 10 is really wrong. If I have to choose a base other than binary, base 16 is a very good one.
Yeah, really.
Now, why is base 16 so nice? I mean, I know you guys are just waiting to get out of the gate. But why is 16 so good?
More values and less characters.
It's very easy to convert from base 2 to base 16. The one thing that's really bad about base 2 is the number is super long. This is 19 and 7/16. What do you need to express 2 billion? That's an easy question to answer. 1 billion requires how many digits to represent it? 10 binary digits or 10 bits is about 1,000. 1 billion is 1,000 to the power of 3, which is almost the same as 2 to the power of 10, and then the whole thing to the power of 3. So 30 bits to represent 1 billion. 2 billions will require 31 bits. That number is going to be big, I mean long, because it's all zeros and ones. And that's why binary numbers are not really so nice, because in order to represent any actual values, you need a lot of digits. But base 16 is very good, because base 16 means each digit can represent exactly 16 possible values. The conversion between base 2 and base 16 is easy. I can explain that in 3 minutes. Okay, it's so easy that once you get used to it, it's like, oh, okay. Okay, I just start with this. Okay, it's somewhat arbitrary, but it's not truly random. True randomness is really hard to come by. Okay, so the first thing you do is you chop it up in 4 bits chunks. Okay, can we do that? From the right hand side, okay? So here's one chunk, here's another chunk, another chunk, another chunk. Wow, it just, it's even. Let's make it not so even. It was not intentional, okay? Okay, this is not so even anymore. Now, for each chunk, find the corresponding hexadecimal value. Okay? You can look it up in a table. I can give you the table. 0 is just 0. 0, 0, 0, 1 is 1. 0, 0, 0, 1, 0 is 2. This is 3, and so on. 1, 1, 1, 1 is F. Well, I promised 3 minutes, so this is how we can. This is how we warp time, right? Okay, but anyway, it's a table with 16 items. Okay. So, at first, you will not have memorized the lookup table, so you just have to look it up for every 4-bit chunks. You have to look up the table. This is 5. This is, I think it's a B. This is A, 7. This is B again. Oh man, repeating patterns. This is a D. So this bit pattern has a hexadecimal base 16 representation of 5B, A, 7B, D. It's that easy. What if I give you hexadecimal values to begin with and want you to convert it to binary? Same lookup table, opposite direction. It's that easy. Why is it so easy? Can I do the same trick with base 10? No. Why not? Because 10 is not a power of 2. Okay? That's why it doesn't work with base 10. So my platform, if I were a politician, is to convert everything to base 2 and base 16, because those two are very interchangeable, very easy to convert between those two. Okay? So your homework assignment is to do the homework assignment that I gave you a little bit earlier, and also to read, not this one, but this module here. So go ahead and finish this module. Read the whole thing. It's not really hard reading. If you have any questions, bring those questions on Tuesday next week. And don't forget your homework assignment to set up the Linux environment and stuff like that. I'm going to move on to room 126. So if you want me to help you set up the environment, we'll be in room 126.